Hello and welcome everybody to our SFSS and SERIS webinar on an outlook on nearshore floating solar PV plans and potential in the Maldives. I'm Stefan, recently re-elected president of the Society of Floating Solutions Singapore, and I will give some brief welcome remarks. And first and foremost, I would like to extend my gratitude to our distinguished speakers, Dr. Serena from our co-host SERIS, Mrs. Mahasti from Canopy Power, and Mr. Aiden from Huawei, Singapore. And I would also like to thank our SFSS council member, Danny, for his important role in organizing this event. He later will be the moderator and then will also say some brief words of welcome. And I also want to thank SERIS, obviously, the Solar Energy Research Institute of Singapore, with whom SFSS shares a strong commitment to advancing floating solar PV systems. For more information on our society, please visit our website or consider subscribing to our social media, in particular LinkedIn and Eventbrite. Eventbrite you already used to register to be informed about our events. There's also a membership option, obviously, to support our work, receive discounts on our events, be featured in our social media, and support also a variety of other outreach activities. I also will come back later to that in regard to our upcoming World Conference. Floating solar PV is a very important topic for our society, and I will also later give a very brief overview of our previous activities. But before I do that, I also want to encourage you to check out the website and the activities of SERIS, as mentioned, the Solar Energy Research Institute of Singapore, and also to follow up with them in case you have questions regarding their work. So with this event today, we continue a series of discussions about the floating solar PV systems boom in tropical Asia, which is a region with a very large potential for such energy generation. As some of you remember, this series includes, for example, our seminar at NUS in late 2024, our webinar on Malaysia, our site visit to the Sembcorp Tengah floating solar PV farm, our webinar on Cirata floating solar farm in Indonesia, and also our site visit there in late 2025, and now this event. I would also like to draw your attention to a forthcoming very important event on floating solutions, including a special section on floating solar PV, which is our 6th World Conference on Floating Solutions. Following our 5 previous World Conferences in Singapore, Rotterdam, Tokyo, Hong Kong, and Espoo, Helsinki, on 19th to 21st of October this year, we will host the 6th World Conference, co-organized with TCOMS here in Singapore at the Expo grounds, and we expect about 300 or more people to join us this time. The website that you can see here on the slide is already online. Registration and paper submission have opened, so all of you are most welcome to join us in October and to learn more about floating solutions, contribute to the discussions, meet new people, network, and socialize. We welcome academics and researchers, members from industry, regulators, civil servants, and also all others to join us. The event features presentations from all relevant disciplines and also has a dedicated business track within the parallel sessions to connect technical innovation with business strategy. I also encourage you to join SFSS, as mentioned. Doing so supports our work, but it also offers members the opportunity to join the larger network of people interested in floating solutions. And members also receive a discount of 100 Sing dollar on the conference registration fee. And I should mention in this regard that our annual membership fee is 100 Sing dollars, so you actually get this for free if you join for the conference. So now I look forward to a wonderful and very interesting webinar and hand over to Danny. Thank you.
Thank you, Dr. Stefan. Yeah. Good afternoon, everyone from Asia. good morning and good evening to my friends from Europe or Australia. A very warm welcome to today's webinar, an outlook on the nearshore floating PV plants and the potential in the Maldives. My name is Danny Thon. I'm the council member of the Society of Floating Solutions Singapore, SFSS, and I'm honored to be your moderator for this webinar today. For those who may be new to us, SFSS is a non-profit organization. We dedicated to advance the floating solution, particularly floating solar, through the knowledge sharing, collaboration, and industry development. Our goal is to support sustainable innovation in the water-rich region like Southeast Asia and also the island nation such as Singapore and the Maldives. We have an excellent lineup of speakers today. We already start with Dr. Stefan Hübner, the president of SFSS, who just shared with us an overview introduction about the SFSS. Next, Dr. Serena Ling from Solar Energy Research Institute of Singapore, SERIS, will share her insight on the floating PV technologies and developments. Following that, Ms. Mahasti Motazedi, Managing Director of Canopy Power, will discuss real-world opportunities and challenges, including her recent floating PV project in the Maldives. Then, Mr. Aidan Trang from Huawei Singapore will cover smart PV and energy storage system consideration for a floating solar system. We will conclude with a Q&A section as usual, where I look forward to engaging you with all of your questions to the speakers. Without any further delay, please allow me to invite Dr. Serena Ling from Solar Energy Research Institute of Singapore, SERIS, to share with us more about the floating solar research. Over you, Dr. Serena.
Thank you, Danny, for the kind introduction. Let me share the screen. Can you see my screen?
Yes,
Yeah.
Dr. Serena. Yep.
Yeah. Hi, everyone. Good afternoon or good morning, depends on where you are. So I'm Serena from Solar Energy Research Institute of Singapore. Today we are going to talk about some overviews about floating solar technology and its potential, like in Maldives and in Asia. So this is the outline of my presentation. So first we will give a brief introduction to SERIS and followed by some technology and market overview of floating PV. And then we will look at what's the floating PV global potential for inland reservoirs, followed by its potential for nearshore and offshore applications, which is more relevant for today's scheme. So we'll follow by a summary. Yeah, so SERIS, we are a national research institute working on applied solar research. And we are part of National University of Singapore. And then being in a unique location in an urban tropical city, so the research areas that we run in SERIS very much focus on technologies that's relevant for places with space scarcity and then also the tropical climates. So I realized this is very much similar to Maldives, whereby there is also a land scarcity and then it's also in tropical weathers. So this is the R&D areas of SERIS. We range from solar cells to modules all the way to systems. So now, since we have this issue with space, that you notice that the research that we conduct aim to maximize the PV deployment, whereby there's limited space. So for example, floating solar is one of that. And also we also cover like agriculture integrated, which is agrivoltaics, and also urban solar. How do we utilize the urban space? Right. So in terms of floating solar, we are considered as the leading institute globally. And ever since 2014 to 15, like before many people knows that solar panels can be put on water, we started the first, at that time, the largest test bed for floating solar. It was a 1 megawatt in Tena Reservoir in Singapore. And following that, till now, we have been involved in about 3 watt of floating solar projects worldwide. So with this experience, we have published 2 guidebooks together with the World Bank. And then we have also utilized our findings from all this research and draft the standard, the floating PV standard for Singapore, which is currently being elevated to a global IEC standard. So this is the guidebooks that I mentioned that we published jointly with World Bank. So we noticed that it has been downloaded more than 170,000 times. So today is probably even higher. So which means this area is getting more and more popular in the field, and people recognize that floating PV is really getting more economically feasible and meaningful for many types of applications, many places. And then in terms of floating PV technology, so this graph actually illustrates how a typical floating PV system consists of. So there is a floating platform. It can be designed in many different ways, will be shown later in my presentation. And then there will be an anchoring and mooring system which prevent the array from drifting away during wind and waves. And then there's underwater cable connection to the electrical infrastructure, which is either on land or it can also partly on floating platforms. So here we need to make a note that you notice that in some countries, especially in China, there are large area deployments of I would say it's a PV on water because it's on piles, whereby the PV systems or PV panels, they are actually fixed at the location. So in this presentation, we mainly cover the type of floating PV whereby the panels are really floating, so they go with the wave, right? So that's just a scope of the presentation. So in terms of floating PV, so these are the types of floats currently in the market. First one is pure flow. So this is most common for a lot of projects in inland reservoirs, right? So it's made of high density polyethylene. So they are relatively light and flexible, so quite easy to be installed and even scaled to a large installation. And then the panels, they can directly mount on such floats. And then the next one is you still have the floats, which provides the buoyancy, but then you have metal or fiber reinforced polymers for you to mount the PV panels on. So in this case, you provide more rigidity to the panels and then less relative motion. But it also comes with a slightly higher cost, of course. And then the third type is more common for nearshore, offshore applications. It's a membrane-based floating PV. So it's represented by the ocean sun. So this is actually borrowed from the concept of the fishing industry in the North Europe. So in this case, the PV panels, they are directly mounted on the membranes, and then they have a contact with the water. So they share the same temperature as the water. In this case, you have a relatively higher energy yield. And then the modules, they will move together with the waves with higher elasticity. And then the last one, so this one is moving towards the more structures, right? So we call semi or fully closed platforms. So in this case, your solar panels are further away from the water. So they are away from the wave impacts and less contact with the water and less movement. But of course, such system, they come with even higher costs. So this will be mainly used for offshore applications, whereby there's like harsher environments. So in terms of for offshore floating PV applications, still there are 2 ways. So either the system can be very flexible, so you go with the waves, or the system is very rugged or very strong, so you can withstand the combined force from the wave and the wind. So there are 2 ways. So if you look at the chart here from left side to the right side, the system gets more structure rich or more strong in terms of structure. And on the left side, they are more flexible, go with the wave. So in this case, the cost, of course, it also go up if you move from to the right side. So these are currently the typical systems used for the offshore floating PV applications. And then there is actually another type of system that's also used in offshore floating PV is developed by the Ferdowson. So this is actually solar panels. So the whole array is connected in flexible rope mesh. And then you see that each panels, they are actually connected individually. They are floated individually, and then they are connected to the mesh. So in this way, you are actually distributing whatever forces from the environmental impacts, like the winds or waves, towards the whole system, other than concentrating at the certain individual components. So this is also one type of offshore floating PV system under development, and I think has been some testing in Europe. So for SERIS, ever since we start working on floating PV, we have been filling in this database for floating PV projects worldwide. So far we have recorded the installed projects worldwide is like 1,600 projects worldwide. And then there's also in the pipeline 400 projects. So adding up is more than 2,000 projects, floating PV projects in the world. So time to time, we also benchmark this database with various suppliers. And then we realized that this database is quite accurate. Keep tracking of the current projects worldwide for floating PV. So based on our database, at the moment, by end of 2025, there are more than 10 gigawatt peak of floating solar already deployed and installed, installed and deployed worldwide. And then ever since like after 2015, 16 is a takeoff and it's rapidly increased the deployment. And then if you look at the regions whereby the floating PV projects are located, you notice that 87% majority of the pie are located in Asia. And then in this coming year and this few years, you notice that there are also more and more big projects which are bigger than 100 megawatt for each project, and especially in big countries like China and India. So in terms of CAPEX, we keep track of these projects, but not all the projects have the CAPEX information. So out of the like 200 projects that we have the CAPEX information tracked, we noticed that less than about 59 projects have their CAPEX less than $1 per watt peak. Especially if you look at the trend, it's going down all the way until like 2021, and afterwards it just fluctuate roughly around the range of $1 per watt peak. So it's coming to the cost, which is quite economically feasible. And then if you look at the reported electricity price, so here is in megawatt hour. So we divide by 1,000, you look at the whatever cents. So except for some projects in Japan, I think it's partly due to the high feed-in tariff. So most of the projects, they are in the range of 10 to 15 US cents per kilowatt hour. So again, this actually tells you that why the floating PV has been picking up significantly in the past years. These are the examples of large floating PV projects worldwide. And first one is in China, done by Three Gorges. It's 250 megawatt peak in the coal mining subsidence area. And then this is also in China, 100 megawatt. And this is in Vietnam, 70 megawatt. So this is in Singapore. It's in the same reservoir where SERIS start our first test bed of 1 megawatt peak. So then afterwards, Semco start to deploy the 60 megawatt peak floating PV in the same reservoir. And then in terms of worldwide, the largest floating PV installation is actually also in China. So it's in it's the Anhui province. It's done by Three Gorges. So it's a combination of different renewable energy as well as energy storage system. So in terms of floating PV, it's about 650 megawatt peak. Again, it's in a coal mining subsidence area. So this is seem to be a very good place to put floating PV since you're not going to touch the area for many years. And then I think you might also have heard like in China there are projects in offshore like 1 gigawatt peak of projects offshore I think last year. But if you notice, they are not really floating. The modules are not really the floating type. In fact, there are pilings, right? So there's piles for the panels to secure them all the way to the seabed. So that's why we don't count this under this scope. But that is indeed quite a big project, above 1 gigawatt. But if you purely look at the floating type of PV projects of the world, if you look at the pipeline, it's also there's more and more gigawatt scale of big projects coming up all around the world, like different parts of the world. Like if you look at Asia and also like Malaysia, also have the 1 gigawatt hydro floating PV hybrid projects coming up, and Korea have 2 gigawatt of project coming up, as well as Philippines and Thailand. So overall, it's really picking up here and there. And let's look at how much is the potential of floating PV in terms of the energy generation. So first we look at inland reservoirs, right? So here we look at all the inland reservoir spaces in the world, and then we consider that I only cover 10% of the inland reservoir area available. So with only the 10% area, that's already a capacity potential of 22,000 gigawatt peak. So this corresponding to the annual energy yield of 29,000 terawatt hour per year. So which is corresponding to 100% of today's global electricity demand. And on top of that, it also saves the water, like it reduces the water evaporation. The amount is equal to, or actually more than 5% of today's global water demand. So that tells you how much potential for floating PV, just talking about inland reservoirs. And then what about nearshore and offshore? So this is a recent study that we have published by SERIS. So we conduct a offshore floating PV potential assessment. What we do is we are looking at the global sea space within the exclusive economic zone. So these are the areas basically you have the legal authority to install such large systems. And then in this sea space, and then we look at the wind speed and ice formation, also wave condition, all the conditions, and then we try to separate all this sea space into 3 different type of regions. So first type of region is whereby you have less wind speed, like less than 60 meters per second, and less wave height and no ice formation. So in this region, we define that it's you can use the current inland flow technologies. So for that is sufficient. And for region 2, it's whereby it's slightly more wind speed and higher wave height. And then this is where the spaces you can use the existing offshore floating PV technologies. These are sufficient. And then region 3 is the one that we try to identify its more harsh conditions whereby there's no existing technology that is sufficient to do. And then also in the study, in order to identify the suitable areas, we also remove the marine protected areas from this study. And also we remove the top 85% shipping density areas for each region. So eventually we remove all these areas and result in where these 3 regions are located around the world. So you probably don't see too many region 1, which is a bit dark purple color here, but they are typically in the regions, for example, in the Southeast Asia, where there's calm tropical waters, right? But majority, like you see, about 95% of the space, actually, they are under region 2, meaning is sufficient when you use the existing offshore grade floating PV floaters, right? Of course, there are also region 3, which is mainly in those polar regions and all regions with like more severe climates. But for region 1, although you don't see much here, later you will see more clear in the next slide. But the message is here, region 1, which is only 0.5% of the area that we study, they already has the potential of 47 terawatt peak of PV installation, which generates 75 petawatt hours per year. So 1 petawatt is 1 million gigawatt. So we are talking about 75 million gigawatt hour of generation per year. So this is 3 times of world electricity consumption today, which tells you that region 1 is probably already enough for many of the places. And then this, I think with this, you can clearly see into some of the areas, like this is the LCOE map of of different regions. You can see that in Southeast Asia, right, that's the place where the LCOE is the lowest, like less than 20 USD cents per kilowatt hour. And then such place usually exists in the regions whereby it's nearer to the shores. And then if we look at also look at the region in terms of how much percentage of offshore areas required in order to provide enough electricity for the region. So this is the percentage of offshore areas. So if you look at all the regions that we studied, about 85% of the region, they only require less than 2%. So a bit greenish color to dark green color. So only 2% of your sea space up to the exclusive economic zone is required for you to meet the electricity demand of the region, right? And then also globally, you'll notice that more than 50% of the area, they have their LCOE less than 15. So average LCOE less than 15 US dollar cents per kilowatt hour, whereby 34% of them are even less than 10 cents. So meaning in many of the places, it's quite a good idea to consider floating PV. And then if we further dive into a certain countries, you'll notice that, yeah, many of them, they just need 0.2, 0.4% of their coastal areas in order to meet 100% of their annual electricity demand. So this is even just within their terrestrial water, right? And then 70% of the area required is within 10 kilometers of the shore, which means that the cost required for the grid connection is also quite feasible. So while some people complain that the floating PV might ruin their view, let's say if you are in the sea, or it actually affect some water activities. But the reality is that we don't have to replace other ocean use, and it just needs a tiny fraction of the sea, even to meet the energy demand of the whole region. So if further dive into Maldives, so we mentioned that it's pretty much to Singapore, it has the issue of land scarcity. And then for Maldives, there's much more sea space compared to land space. So in this case, you have much higher offshore floating PV potential compared to inland PV potential, right? So if we just estimate how much potential for Maldives using the same methodology that we mentioned earlier. So you notice that in Maldives, most of the place is under region 2, meaning the current offshore float technologies are sufficient to support this area. And then if you compare this with the current major energy supply, which is diesel, I think it's still quite a economical case to consider. And then the potential for all the region, like all the areas surrounding Maldives is about 37 terawatt peak. Again, it's generating, well, it's a humongous number, 66 terawatt hour. Right, so obviously Maldives doesn't need this much. So which means you just need a tiny bit of the sea space in order to meet the energy demand of the whole nation. So you'll notice that the areas with reasonable LCOE are pretty much closer to the shores. Yeah. And then if we look at Maldives, I think the renewable energy capacity is increasing very fast. and it has been double from 2023 to 2025. So currently about 100 megawatt. And then there are different type of floating PV. So I noticed recently, this is the most recent one, the Ocean Sun system, jointly also by Canopy Canopy Power. And then this is each ring. I think there are 3 rings, and then each ring is about 700 kilowatt peak. In total, there's about 2 megawatt peak of floating PV capacity, and also with 3 megawatt hour of battery storage. And then there's other type is called Solar Sea. So this is a platform-based floating PV. So that's the type that is relatively higher in cost because you offer more rigidity. So there were also quite some cases in Maldives for the installation. And then this one I found is in early 2024, close to 1 gigawatt of installation. Right. So the story is in Maldives, of course, if you have space, you put it on rooftop, but you don't have that many spaces similar to Singapore. So we have to consider floating solar, and there's a huge potential for floating PV in Maldives. Yeah, so that will come to my summary. So for floating solar, there's already like huge install capacity in the world, up to 10 gigawatt peak. And then if you look at the current cost, the LCOE is quite cost competitive. And then if you look at the potential for both inland reservoirs as well as for nearshores, they are already even sufficient to meet the global electricity demand today. And even more so if you are to consider a future 100% renewable energy scenario. Right. So yeah, Maldives, given the place, have huge sea space, there's a huge potential for floating PV, and it just needs a tiny fraction of the sea. So the sky is not the limit. Ocean is the limit. Yep, that's all for my talk.
Thank you, Dr. Serena. Yep.
Thank you.
Thank you for many very valuable insights about floating solar research, and moving from technology to the real world application. It may be not really the same. So therefore, I'm pleased to invite our next presenter, Miss Mahasti, from Canopy Power, to share the opportunities and the challenge when her company, Canopy Power, successfully deploy a floating PV system in Maldives recently. Over to you, Miss Mahasti. Miss Mahasti, maybe you can unmute your microphone. Thank you.
Okay, let me share again my deck. Can you see?
Yes, we can see for now.
Excellent. Hello, everyone, and thanks for having me today. I'm representing Canopy Power, and I'm Director of Strategy and Business Development for Canopy Power, and also Managing Director for our branch in Australia, Canopy Power Australia. I'm very happy to be here with you, and especially after Serena's great presentation. As Danny said, I will bring you to a nice trip with me to Maldives to show you the project that we have realized, as Serena showed it in this year in Maldives, which is not one of the largest one, is the largest floating solar in Maldives. That we're very proud of it because it proved lots of points that Serena just mentioned. And I want to share with you the opportunities, but also the challenges for floating solar at Soneva Secret, which is the luxury resort in Maldives that we deployed that for. First, few words about who we are. We are a Singaporean engineering company, 10 years old. In few days, we will be exactly 10 years old. We are specialized in renewable energy, and especially now in floating solar. When I say renewable energy, is any kind of solar. We started with rooftop, with ground mounted, then pontoon base or pure float, as Serena mentioned it, metal structure, and now membrane-based floating solar from Ocean Sun, with whom we have signed a partnership 3 years ago. And now we are the largest engineering company who can deploy their system. Our overall deployment, we started in Southeast Asia, so we have projects deployment in Singapore, Indonesia, Malaysia, Cambodia, Myanmar, and lots of other countries. And then we expand our operation to Maldives. As you know, we will talk about India, and also recently from last year in Australia and Pacific Islands nations. What I want to share here with you is our project with Soneva Secret luxury resort in Maldives. Few words about who they are. So they call themselves ultra luxury resort. As if you're familiar with Maldives, you know that it's almost a nation of resorts, and all the resorts are luxury resorts, very high level luxury resorts. And one resort equal one island. They have their own private island. And now there are plenty of them in Maldives. And the competition become quite important. And now we see for the first time the level above, which is ultra luxury resort, coming up with only 14 villas, when you can compare with other regular, not regular, still luxury resorts. They have about 100 or 150 villas. Soneva Secret decided to go for 14 villas, but provide a very, very luxury experience and services to their guests. So the Soneva Secret is the third and the latest resort from Soneva Group. So they have in Maldives that we work also with, more on the rooftop solar and ground mounted, but soon also floating. And they are very, very committed to sustainability. And this resort, which opened actually mid last year, from the beginning, from the start, they wanted to have the highest renewable energy penetration. It means that they wanted the maximum percentage of the electricity they are using for their operation coming from clean renewable energy, typically in that case, solar. This is a very, very ambitious goal, especially for a new resort. And we were working with them even before they finished the building to make this happen. And now it's there. And from last year to now, as you can see, they have lots of also awards in terms of customer experience. And it shows also the point that Serena were mentioning, that having the floating solar, it's not only impacting negatively the customer experience, but actually it has a very positive impact. Some study in Maldives shows that the guests, before choosing a resort, they look at the sustainability of the resort in an overall point, and they are ready to pay 20% more to go to a resort when they know that all their activities and operation are sustainable. And now it becomes a competitive advantage, and later I will talk about it as a opportunity as well, because this is valid also in other island resorts around the world. And we were talking about Pacific Islands, but same thing in Indonesia, in Malaysia, in Caribbean islands, everywhere. So that's something to keep in mind. Now let me talk a little bit more about the problem we have solved for Soneva Secret, as I told you from the beginning. First thing, high cost of electricity. In Maldives, all the islands, so all the resorts, are completely off grid. There's no grid at all. The only way they have electricity is to a diesel genset generator, which means that they have to pay the cost of diesel. And 100%, if they don't do anything, especially with us, they have to pay high cost of diesel because it's very high because of the remoteness of the area. You have to pay diesel to transport the diesel to the resort. So you're double penalized. The cost of diesel is quite high. And also, not only the cost is high, you are dependent to diesel, to two things. One is logistic of the diesel. It happens sometimes before that, for whatever reason, COVID, or now what's happening right now, some geopolitical issues, the delivery of diesel is not happening. So you can imagine a resort like this, without diesel and without electricity, their business is gone. Second is dependency to diesel is dependency to the price of diesel. It means that their bottom line, their result, their profit as a resort depend directly to the price of diesel. And that's something, of course, they cannot control. It means if it will go up, their profit will go down without them being able to do anything, and it will go down. Okay, they are happy, their profit will go up, but it's not predictable. And as I'm sure all of you are running businesses, you know that a business which is not predictable is a headache for the company, and no one likes this. The last, and Serena mentioned it also, is the land and roof area. As you can see on the photo, this is an actual photo of Soneva Secret. It's a small island, and they don't have enough land to put a solar farm, and they don't have, and the roof also, because of aesthetic and also even the size of the roof, they are not enough to make them be able to reach the goal of having the maximum sustainable energy and renewable energy. At the beginning, of course, we did some calculation to see if we cover everything, which is, of course, is we will not do, and they didn't want to, but just for the exercise, if we cover everything, if they will have enough to electricity to cover their operation, the answer was no. So it means that they will have to stay with the diesel genset and the problem that you can see in terms of high cost of electricity and dependency, or move to a new solution, which basically is a floating solar. And they were, and we, I don't know if I mentioned or not, I don't think so, but as an engineering company, we are completely technology agnostic. It means that we always choose the appropriate solution for the appropriate location, for the needs of the client, etc. As I told you before, we can install rooftop, or we can install solar farm, or we can install any kind of floating with any kind of battery. Why we will choose one instead of another is because of our 10 years of expertise and knowledge and of the location of our clients, of their business, of the what we have seen in the past project in the remote areas where we are specialists of, and we recommend them to go with the ocean sun technology, which in our opinion is the best technology for. It's a floating solar technology for Maldives because it can be installed near shore or a little bit more even offshore. Price performance ratio, it's unbeatable. And also it's much easier to install and to maintain. And it provides what we need to serve basically in that case Soneva Secret. And what also we, so I will move to the next one, so I can talk a little bit more about. So now you know the problem. The solution we propose them, it's this, and these are once again the actual photo of the project. What we install is 3 floating rings and a battery, a large battery from so the floating ring from Ocean Sun and 3 MWh of battery from Huawei. Which is why we choose Huawei is the same case as before, because we can install any kind of battery in any kind of operation, but we always go for the best and the most appropriate one for the location. And after of course studying different solutions, Huawei was the best. And at the end of the day, we as an engineering company, we are the one taking responsibility for the whole system integration and the results and make it work, and also O&M of the system. So that was our choice. And you can see that it provides a cost reduction of 70%, which is very sustainable, a very important number, 80% of renewable energy penetration. And this is thanks to the sizing that we have done with these 3 floating solar rings and the battery. If you don't add battery, the maximum you can reach with any kind of solar, it's 10-15%. The battery allows us to go as high in terms of renewable energy penetration. And I was talking about our choice in terms of best cost performance ratio. You can see that the payback period of the whole system is 4 to 5 years. And I will tell you one thing. This calculation was done last year where we started the project and we signed a contract with, or 2 years ago with Soneva Secret. right now, if you look at these numbers with the price of diesel after this geopolitical situation, in less, I would say in a year from now, all the system is paid for. It's impressive. And the minute we connect the system, the floating solar and the battery, they start seeing the saving. As you can see, in terms of carbon emission reduction, we reduce over 2,000 tons of CO2 emission each year. But also mainly because we let them, with this solution, they can turn off the genset 16 to 18 hours per day. And it makes them save up to 1 million liters of diesel per year, which is huge. These numbers are huge for a resort in Maldives, and I'm sure anywhere else. And when you look at the price of diesel, once again, compared to last month, I'm sure you cannot even guess how much increase we had. In Maldives, the price of diesel compared to last month, March compared to February, has doubled. Literally doubled. It's crazy. And even if they are ready to pay for double the price of before, not all the resorts will have enough diesel because there is a shortage of logistic and overall shortage of diesel in Maldives. And these guys know they are king of the world in Maldives. They are almost the only one who can serve their guests like nothing happened, because for them nothing happened. And I was talking about competitive advantage. This is a competitive advantage on top of the choice of the customer at the beginning, which they select the resort with the more sustainability. And it's very interesting. Here you can see the visual of the rings. Actually, when you look at the rings from far, they are quite flat, so you don't see it so much. But funnily, at the beginning, when we start discussing with Soneva Secret and actually other resorts that we are talking to, and soon we will announce also the deployment, they were all asking us, based on their old habits, like where they used to ask us, put all your solar on the roof in the back of the island in the staff area so no one can see it. They ask us, okay, put your floating ring and design it for the back of the island so it will not be visible by the guest. And during the construction, what happened is they come back to us and say, you know what? Install your floating solar in front of the main jetty when our guests will arrive, because we want them to see it, because this is a competitive advantage. And that's what we did. So now it becomes really important for the resort to show it, and they even go crazy. So this is a protected area, right? Going back to your point, Serena, before. This is a protected area, and we are very sensitive about the corals, but actually we have studies from different universities that we are working with that I can share with you later, Serena, that it actually helps protecting the corals because it reduces the temperature of the water. So the corals start growing below these floating rings. And also these guys, they are going crazy. They say, oh, what about at night? We start putting some light show and we start organizing some snorkeling or even diving below these rings or around these rings because the corals are coming back and we see a new float of fishes coming, etc. And we had to, on this one, we had to calm them down. You say, hey, this is a very critical system. Don't let people go and dive or snorkel around or don't organize any light show. Just use it as it is nice enough already. So these are the kind of competitive advantage I'm talking to. And all this, once again, is coming from the resort themselves. So I promised you at the beginning to start to talk about challenges and opportunities. So the challenges with this kind of situation, this kind of solution is, if you look at compare it to the regular solar rooftop or solar farm or ground mounted, etc., it needs a completely new set of skills on top of the solar and battery, which are the marine and maritime and mooring skills. It's not a joke to install a system like this on the water and on the ocean. We install it on a reservoir as well. It's already, you need to have very strong skills and experience and study skills and to look at what exactly you're doing in terms of stability of the system, in terms of impact on the environment. There are lots of parameters that you have to have on top of this regular solar skill if you want to install on the rooftop, for instance. And you can imagine now on the ocean in Maldives, when there are strong winds, strong waves, you have to make sure that everything is safe and secure to have a successful floating solar installation. And as also we are in charge of O&M of this system, management and operation, we want to make sure that from the beginning we design the system properly. That's a challenge. It means that the entry ticket for regular solar companies to go in and install is quite high, I would say, or you have to invest a lot to be able to have these skills. The other one is for ocean installation. The Serena showed four different kind of floating solar. The first two, they are not the right solution for nearshore. The third one, which is the membrane base from Ocean Sun that we are installing, we really believe is the right one. And then you have other ones that, in our opinion, is much more expensive and is for other type of installation, for instance, near a wind farm to provide additional electricity or other things that later I will talk about. So these are the challenges we see with the ocean installation or floating solar versus solar. Opportunities, as I talk a lot about, it's about reducing this diesel dependency in all island nation area. Here we discuss specifically about Maldives, but you can exactly project the same thing in other areas, and of course customize it, because here it's a resort, but there are other commercial and industrial activities that we can address in Fiji, in Mexico, in Indonesia, etc. And the last, which is a big opportunity that we are seeing as Canopy Power with this solution, is to help deploying electric vessels and electric boat, electric marine transport. And you can look up. Last week we announced, we make an announcement. We signed an agreement with Candela, which is the small boat you can see here, which is a hydrofoil electric boat, which in our opinion, once again, in our engineering opinion, is today, as we are talking, is the best in the market. We signed an agreement with them to provide with the floating charging station for their boat, because they are deploying next quarter. You will hear that in Maldives, it will be a water taxi company with 10 of this hydrofoil from Candela, which will start the operation. And once again, it's very well welcome, especially right now with the cost of diesel in Maldives. It means that you can travel from Malé airport to the resort, to different resorts, with this kind of solution, which is also, because it's hydrofoil, it's very stable, so you will not get seasick, and also you will not have the smell of the diesel, you will not have the CO2 around. And we are providing the floating charging station based on the same floating charging floating solution that you saw. And this is for us, it will be the future and the game changer to deploy more and more electric vessels, because it's exactly the same situation as EV deployment. The EV didn't start picking up before having the right charging station in place. In Singapore, no one wanted to buy an EV because people didn't know how to charge it. But the minute the charging infrastructure start coming in, and you start seeing it around, and the people start buying EV. So it's a help to it's actually, it's not a help. We need to have a charging station for electric boat to make sure that the deployment will happen. And that's what we have announced. And I will not spend more time here, but you can go and Google it, or go to our LinkedIn page or on our website, and to know more in detail, and to contact me if you have any question.
Thank you. Thank you, Ms. Maha, for sharing with us your practical experience in developing a floating PV in an ultra luxury resort. It's really amazing. So I believe all of us here want to visit this beautiful floating PV system by ourselves one day. I believe so.
I hope so. I hope for everyone to do that.
Yeah. So next, Mr. Aiden Trang from Huawei will share with us how he can help Canopy Power to integrate the floating PV system with the latest innovation through the smart PV inverters and ESS. Yeah, over to you, Aiden. Yeah.
Thank you, Danny. Let me just share my slides. Okay, can everyone see my slide?
Looks good.
All right, okay. Hi, everyone. Just firstly, a short introduction for myself. My name is Aiden. I'm from Huawei Singapore Digital Power Business Department. So actually, for these Canopy Power projects in Maldives, we've been working with Canopy Power since day one. Even at the pre-design stage. So this is also one of our flagship. You can say that flagship microgrid sample site in the APAC region, right? So I just now I think Dr. Serena and also Ms. Maha already did a very good job explaining on the floating PV as well as very project specific use case in terms of all the challenges and the solutions. So for me, actually, I want to come in from a different angle rather than zoom into specific projects or use case scenario. I want to offer you an overview of the current trend and also on the PV plus BSS combination for such microgrid or off-grid applications, and what are the considerations that you should be looking at when you are selecting a BSS supplier, or rather the whole solution itself, right? Okay, so just a little bit of overview, introduction for Huawei as a company, right? So we are a leading provider of ICT infra and smart devices. Traditionally, that is our bread and butter, right? So globally, we have more than 200,000 employees, and more than half of our employees actually work in the R&D departments, right? So covering 170 plus countries and regions. And basically, we are actually heavily invested in R&D development. All right, so we have, in short, that we have different business group. We have consumers, covers all the endpoints like tablets, phones. We have carrier networks, and we have enterprises business. So for us, actually, for the renewables, it's for under digital power. So we see that we have smart PV and ESS. That's where we are. We are at now. Then we have EV charging network as well as data center facility and critical power business unit, right? So in terms of the business outlook for our digital power business, year on year, we are seeing a very stable and steady growth and quite substantial. So when we look at, let's say we look at the on the solar side, traditionally PV inverters, we actually rank world number one globally. For almost 10 consecutive years until up to 2024, and totally we have reached 176 gigawatt in terms of shipment, right? So for ESS or BSS grid forming, BSS, cumulatively we have global shipment more than 36.5 gigawatt hour at this point, right? So other than that, DC ultra fast charging, DC business, DC modular UPS, and so on and so forth, right? It's just the overview of the business. Now, if we look at the trends and challenges in terms of solar and ESS or BSS as a solution, right now we have many use cases or business models that we can apply. Like in different countries, we have different business model, business use case, right? So over here, for the microgrid or off-grid application in Maldives, that's the last one we are looking at, right? So other than off-grid applications, this combination can be used for frequency regulation. It can be used for peak shaving, can be used for TOU, time of use, can be used for maximize self-consumption. Right. So if we zoom in to the to all these widely adopted applications or use cases, what are the things that what are the challenges that we are looking at if we are incorporating ESS into our overall solution? So number one concern or number one challenge is on safety, right? Fire safety, because I mean battery BSS, I mean FFP battery itself inherently there is a fire risk, right? So I mean just 2024 alone, we have more than 100 plus safety accidents. I mean globally publicly known accidents, right? So that's the number one priority, safety, when we look at the BESS system, right? So second, for the overall quality and also the performance efficiency of the system, this can because this can be translating into dollar value in terms of your ROI, in terms of your payback period, your revenue. I mean, even for the for your capex and opex, all these. The system efficiency or performances actually can directly contribute to those numbers. All right. So from Huawei perspective, what we are able to offer is the end-to-end solution to cover all these use cases, right, or business models. Right. So from PV inverters, we've already, for we talk about CNI, commercial and industrial PV inverters, plus our CNI smart ESS. It's the cabinet type where it was deployed in the SSR project in Maldives with Canopy Power. This is the one that we actually deployed. It's the cabinet type, not the containerized solution. Right. So also, on top of PV plus ESS, we also can incorporate EV charger, DC ultra fast charger into this equation as well. So from the generation side to the storage and also to the EV charging. So we have the one fits all solution for all these application cases. Okay, so now how do we choose and ESS or BSS? What are the criteria? What are the criteria that we should be looking at? All right, so just now I already mentioned, I think number one, safety is always the top concern, is the top priority. So firstly, safety, then I will group this 2, 3, 4, 5 into one category, which is under system efficiency or performances, which affects your overall the whole life cycle cost, your LCOS, right? So, and lastly, we have the one fits all, 5 easy. Is the one solution fits all offer that we are able to provide to our customer, either end customer or EPC customers. Okay, so just on the safety front, I think for us we call it C2C dual link safety. What is dual link? Dual link, that means we have two different direction. One is on the electrical side, the other one is on the thermal side, right? So C2C is from cell level all the way to consumption level. So on a cell level, in terms of thermal insulation or for the on the cell level, we have a heat insulation pad is in between cells. On the pack level, we have a positive pressure oxygen blocking design. So there's to ensure there's no oxygen that can enter into the pack itself, right? Then on the system level, we have a unique directional gas exhaust system to channel all the, the exhaust from at the system level. And lastly, at the consumption level, we have a top explosion ventilation. So, this is for our CNI ESS, this is the patented design. Is the ventilation is from the top, not from the side. Okay, then for individually, I'll just show you a video, a short one, to see, in terms of the conventional design and versus our right. Okay, let me share it without the system sound. Okay, so just now that few small video clips is, just basically it's from cell level, pack level, and system level. We did some actual tests to prove, to showcase that, on a different level, the mechanism that we put in is actually effective. And in comparison, what is the, traditionally what will happen, and with those safety mechanism, fire safety mechanism in place, what will happen then? That means, in short, there only will be gas, but there won't be fire and no explosion. So our CNI ESS also has been awarded the world first highest safety, standard safety certification by TUV as well. Okay, so that's on the safety front. So in terms of the rest of things like RTE, your DOD, and your, in terms of utilization, system reliability, these all are actually can be grouped under the contribution to a lower LCOS, right? So in terms of maximum system, your system efficiency RTE, the highest that we can achieve on the system level is 91.3, and for the overall life cycle SOH, your SOH at the during the battery life cycle, overall we can increase the usable energy for the system by 2%, right? So that's on the K-packs, and on the low packs, for our, because this is a liquid cool system, so there's for the coolant itself, 10 years you don't have to replace the coolant at all, right? Then we have also embedded this automatic SOC calibration, so you don't have to do a manual SOC calibration. You don't have to deploy people. There's no man hours, labor costs, and you don't have to schedule your site visits for maintenance, just to calibrate. Just to calibrate the SOC in individual battery pack. All right. So on the other front, for our by design, that this CNI ESS is actually very much space saving. Even for the Maldives, for the Soneva Secret sites, there is also space constraint in a way. So how do this system benefit the whole site requirement? Because we have, in terms of design, side by side, the clearance is only 0.1 meter required. And traditionally, front to back, the setback distance should be about 0.6. But for our CNI ESS, the required setback distance is only 0.3 meters. Right. So that's, for the on the cost or on the dollar sense, this is also one of the considerations when you are selecting a BSS system to add on to your PV or to as a standalone system. Right. So lastly, we have this for us, because the whole system in terms of PCS, battery pack, cooling system, your BMS, it's all prefabricated in one cabinet. So quick installation. In terms of commissioning, it's very easy. It's very simple, right, for the EPC to actually, to deploy the whole system, right? So for the design wise, we have a 3-phase 4-wire PCS with a neutral wire. So this actually eliminates the requirement for isolation transformer. So it's a direct plug and play. You don't need additional transformer. Isolation transformer to add on to your overall project cost. Okay. So lastly, I believe this is one of the pain points from many, even for Canopy Power in the previous project or prior experience. So if we have, the end-to-end solution, you only have to deal with one supplier and one vendor and one counterpart for the entire solution, not on the individual component level. You can get inverter from vendor B, you can get ESS from another vendor. In terms of integration, it might not be so smooth in terms of your, these are hidden costs, and these are in terms of efficiency, is not there, right? So that's, for the material is that's all I will share for today. Then because I'm supposed to have actually a video clip for the Soneva Secret project that we did a showcase video for that. Because I'm dialing in from without the company firewall, so I can't access that video, unfortunately. I think we'll drop the.
You can find it on the homepage of Canopy Power. It's you just go to canopypower.com. The video is the first thing you will see on the homepage. It's a 3-minute video. I recommend everyone to go and see this, specifically about Soneva Secret project.
Yep. Yes.
If you like, you can also post it in the chat. If you find time during the Q&A session. If you're getting flooded with questions, it's a bit more tricky, but there's this option. Just a minute. Thank you.
Yep. Yeah. Thank you, Dr. Stefan. Thank you, Aidan, for the very informative overview of the current trends of the PV Smart ESS and microgrid from Huawei. So now we will move to the Q&A section. So please feel free to submit your question in the chat. And I think in the meantime, we already have a few questions for Ms. Maha and Dr. Serena. So maybe I can share some of it first. So for Dr. Serena, so basically there's one question and regarding about the study, the research of the SERIS. Is it public for everybody to access, or yeah, or if they want to approach this study research from SERIS, what should they do? Yeah.
Yeah, I think it's referring to the floating PV database that I share. So far we keep it as an internal database, but if you have any like interest getting some information regarding the database, you can contact us and see how we can help there.
Yeah, sure. Thank you so much, Dr. Serena, on
Yeah.
behalf of the audience. So if anyone want to know more about the floating PV, at any time you can drop the email to Dr. Serena to get some information from SERIS. It's very informative and very useful. Yeah. And I think next question I will share with Miss Maha. Yeah. So Miss Maha, there's one question regarding about harvest the rainwater from the solar rings. So is it Canopy Power is doing that, or maybe Soneva Secret considering this? Yeah. You might share
The
about
answer
this.
is absolutely yes. Yeah, this is something I didn't mention because it would have made the presentation much longer. But that's another huge benefits of these floating rings. The full surface of the ring, which is 70 meters of diameter, so it makes a surface of 4,400 square meter, collect rainwater, have the capability to collect rainwater, which in Maldives, once again, but in lots of other places, the two main problems are electricity and water. So, and we are talking about a lot of water. We are talking about tens of millions of liters of water per year. And surely Soneva Secret has a huge plan to collect this rainwater. For the moment, it's not part of the project, but they are working on it because it needs the infrastructure also to collect water, to decide what they want to do with it, how to distribute it, if they connect it to the existing distribution system they have. So that's a project that they are doing. We are not specialists of water, but we provide them the infrastructure to do it. And it will be live within a few months normally. But that's a huge benefit of this system also compared maybe to other floating solar that we have installed.
Yeah, definitely, totally agree with you, Miss Maha. Yeah, thank you so much, Miss Maha, for your answer. And please allow me to come back to Dr. Serena. So, Dr. Serena, there's one question from Songha. Yeah, so his question, yeah, I suppose so. Did your study consider the environmental and social aspect of the FPV when scaling up? Yeah, yeah. So
Yeah,
I
so
believe,
for
yeah.
Yeah, thanks, Danny. So basically, for all the studies that we are involved, all of them involve environmental and social aspect of the studies. But usually, this kind of project is a consortium of people with different backgrounds. So we come in with PV experts, and then there's also environmental and social experts who is working on the elements that you talk about. And then, like for example, I mentioned we had a 1 megawatt test bedding in Tuna Reservoir. So with that, PUB, which is the Public Utility Board in Singapore, they actually require that there has to be this environmental impact study. So afterwards, the result is that following this test bedding, SEMCO deployed the 60 megawatt. So that roughly tells you what's the outcome of the study. But we do, or like for all the projects, it's actually required, and we really look into based on different places. Some places has some species, right? Some has coral, or some has other environmental concerns, but they are all addressed at least from the pre-feasibility study stage. And then I'm happy to hear that Maha just now mentioned that they see the coral actually grow more below the rings. Yeah, that's interesting to know.
Yeah, I think Dr. Serena, yeah, Dr. Serena, I'm not sure when when we do the same floating solar last year together with the PON regarding the the floating project, the biggest floating project in Southeast Asia, in Indonesia,
Yes,
Cirata. So I think,
correct.
yeah, maybe, yeah, Park Harry also mentioned, yeah, the environment over there getting better after installing the floating PV. Yeah.
Correct. So there are different places they see different observations, but relatively it's on like majority I would say is on the positive side.
Yeah. Thank you for sharing the answer, Dr. Serena. Yeah,
Thank
I
you.
totally agree. Yeah, environment is always our first priorities. Yeah. Thank you, Songha, for your question. And next question, please allow me to come back to Miss Maha. Miss Maha, so there's one question regarding the anchoring system. Is it Canopy Power using the dead weight or maybe counterweight for this nearshore installation?
So depending to the installation and to the location, we have different method of anchoring, even more than dead weight or counterweight. So it really it goes to a study. We do a site survey first and site study before deciding what is the best solution. In terms of Soneva Secret project is a dead weight. That's all I can share with you at this stage. But it's
Yeah,
a case.
thank you, Miss.
Sure.
Yeah. Yeah, I believe anchoring the floating PV system is very important. And I received one question from one audience from Vietnam, IPC, Mr. Tong. So his question is, please provide maybe an introduction to the float system and explain how we can secure the float in the tide rise and fall situation. Yeah.
Okay, I think that needs
Miss Maha,
another session maybe for that. All I can tell you is there is a floating ring which is covered by a membrane, and it's the floating ring which is anchored, and the membrane is a flexible membrane, but it's strong enough still for people basically walk on it. And that's I segue this to answer to a question about O&M that I saw before. Basically, it's for us is much easier to maintain and to clean the panels on this kind of floating solar, because we can literally walk on the membrane and go manually basically clean the solar panel instead of regular pontoon base that we install on some reservoir that we have to have a specific system to do the O&M and the cleaning services.
Yep. Yeah, thank you, Miss Maha, regarding about anchoring the floating PV system. Very important for the system. Yeah. So maybe the next question, please allow me to come back to Dr. Serena again. So regarding the so-called government considering on the onshore FPV. So even though this FPV is on within the EEZ of the country, however, it seems quite an open area for the national source of the electricity and part of the security. Yeah. So is it there's any measure so-called regarding the national security measure involved, or we need to particularly so-called be aware when we deploy so-called FPV in the onshore or nearshore?
Yeah.
Yeah. I think this
Thanks for
question,
the
please allow me to.
question. Yeah, thanks for the question. I think it's a very valid concern, because if you are installing a system very far from the shore, so you do actually have the issue that there is higher cost for or higher measures that require for this security related things. But I would say each country has their own policies, and then internationally, I think this kind of installations at the like exclusive economic zone, they will be considered as like critical infrastructure for the nation. But we say that let's say all these regions that we study, they need to say 1% of the sea space for floating PV. But it doesn't mean that you have to deploy all the 1% that I mentioned, because you still have other source of energy. Let's say even for solar, there's rooftops, there's lands. I mean, for many countries. So it's just give you the potential that how much floating PV can offer. And also from cost point of view, I think you have a similar question earlier also about this offshore. solar PV costs compared to rooftop. So if you have rooftop or if you have land, obviously you want to put on land or put on roof. So when you go to floating PV, it's in the case that you don't have much space left. Like in the case of Maldives or for Singapore, we have a land scarcity issue. So then we look into the ocean deployments. So even for the ocean, what we think is economically feasible is you try to install in the area that's still closer to the shore. In this case, you actually minimize the cost such as the subsea cables, right? You don't want to have it very far away from your shore, and then you pay a high infrastructure cost, and also for the O&M, it's also higher cost for you. And the only exception is in some countries if they have the wind farms. So they already have an infrastructure like very far off the shore. Then they have already the subsea cables connect and transmitting the power back to the shore. Then you can install solar at that place and utilize the same subsea cables. So I think your concern is valid that there is some economic consideration, and then there are for both floating PV, offshore or nearshore, there are cheaper options compared to deploy very far away from the shore.
Yep, thank you for your insight, Dr. Serena. Definitely, yeah, this is those measure and also thing that we need to concern when we deploy the FPV nearshore and or offshore. Yeah, and please allow me to go back to Miss Maha. Also, one of the very interesting question regarding O&M. So, Miss Maha, so how may I know how the O&M is being done for the ocean sun structure? So how about the cleaning? Are you going to use the robotic cleaning or manual with the brush? Yeah. Do you mind to share a little bit more with the audience here? Yeah.
Yeah, I think I mentioned a little bit this before. So we plan to do it manually because of accessibility of the floating solar, and the structure of floating solar itself allow us to go on the ring, literally walk on the ring, and have access to the floating solar. I would say this is also one of the main advantage of system as we see it, is even easier for us to do the cleaning of this kind of solution than the rooftop or some ground mounted that we have installed somewhere else, or even some pontoon based on reservoir, because it needs a different kind of access and it's a little bit more complicated. So I would say quite easy to clean, and it's done manually, no robot at this stage.
Yeah, so we have 20 or 25 years on waiting for us. So O&M is actually very critical topic. And so Ms. Maha, I think also same question for you also, quite related to O&M. So we have audience Kochun from Singapore. Yeah, so his question is, as you know, in the floating PVs, the DC, the DC side, like the DC cable, DC connector, DC panel will be so-called a big challenge for all of us. So is it by using the ocean sun floating ring, the cable, the connector issue will be lesser? Or yeah, I mean, any experience from your side? Yeah.
Yeah, of course. So I don't know if the question is compared to pontoon-based floating or is compared to the regular solar. But what I can say is, despite what at the first impression we can think, there is no salted water on the ring at all. And if there is some water from, for instance, rain coming on the ring, there are pumps on the ring which remove the water from the surface of the floating solar, and that's actually one of the things that we use to collect rainwater. So I would say no salted water. If there is water, it will be a clean water, not clean water, rainwater, and that we pump out quite rapidly. So far we haven't seen any specific issue compared to for the DC cable, etc. I would say intuitively it will last less longer than on a ground mounted, but it hasn't been proven yet. We haven't installed it for more than 10 years now to see. But compared to pontoon base, I would say it lasts longer. same thing, you need more experience, but from what we can see so far, I don't see any red flag or any challenges in terms of cable or connector.
Yeah, thank you, Miss Maha. Yeah, I really appreciate. About DC cable, DC connector, and etc. regarding the DC. Yeah, it's always a headache for all the
Oh,
solar
yeah.
EPC. Yeah.
Oh, yeah. Especially in remote
Yeah.
areas like in Maldives.
Yes, totally agree. It's not easy to do the O&M, the troubleshooting. Yeah.
Yeah,
Yeah.
yeah.
So
Even
maybe
during the
please allow
project
me to
installation,
give
if
one
you
question.
don't plan for your project properly, you're in a remote area and you forget to order a cable or a connector, just one piece, the whole project will be stalled for a few months, the time you order and it comes to Maldives, etc. So very, very important point. Sorry, I caught
Yeah.
you were talking.
No worry, Miss Maha. Yeah, really, those practical experience, hard learned lesson. So I think all of us here will appreciate from what you experience for this project. Yeah, and for the next question, please allow me to pass to Aiden. Actually, Aiden already answered in the chat box. However, please allow me to share the question here, so maybe other the other audience can learn from your answer as well, Aiden. Yeah. So the question for Huawei is regarding the different technology solutions shown from the Huawei just now. So is it the Huawei tech could fit in a marine environment along the linear cycle of the FPV? Yeah. So maybe Aiden, can you help me share a little bit more about your technology? Yeah.
Yeah, I think for inverters, I think everybody knows that we've already deployed many like floating solar projects over the region, right? So I believe it's more on the ESS on the battery energy storage that the audience is referring to. Yes, I mean the short answer is yes, because if the system itself is C5 medium anti-corrosion, already has that protection rating. So it's designed to endure such a harsh environment, and especially like nearshore kind of application. So that's exactly, especially over a few years. In reality, you might see let's say you have a apple-to-apple comparison with the competitors, then you will see the difference in real life. Now it's too early to say, but give it a couple of years, then we shall revisit this topic again.
Yeah, we will visit together. I hope so.
All right.
Yeah. So thank you, Aiden, for your answer. And please allow me to share one more question from one solar developer from Vietnam, CME. So they have a question regarding the using the seawater for cleaning the PV module at a floating system. Is it recommended, or is it any other so-called other solution for cleaning the PV module at the FPV at the moment? Yeah.
No, we don't use. We don't recommend, and we don't use salted water, of course, for cleaning. For the PV itself, and also as we were talking about the connectors and cables, we don't want to reduce their lifetime. Also, what we do is we use the rainwater and the fresh water that we collect directly from the system. Yeah, much better.
Yep. Thank you. Yeah, I think salt water is they give us a little bit trouble in the long run. So yeah, fresh water I think is still recommended. Yeah. 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 So another question, I think again for Canopy Power. Yeah. Yeah. So there's one question regarding the so-called wave heights and exposure time during the testing. So is it Canopy Power together with another party? Do you test about this wave height and exposure time? And maybe you
So
can
these
share a
are
little bit
tested directly
insight.
by Ocean Sun, who's providing the technology, and they have a full set of tests and also certification. You can imagine that's the first thing that we have checked before taking any integration responsibility or this kind of solution. And as you may know, Ocean Sun is a Norwegian company, and as I think Serena mentioned at the beginning, this technology is inspired from the fishery, floating fishery system that they have in the Northern Sea. And you can also easily imagine if it's last in the Northern Sea, it can easily last anywhere else. But they still have a very serious testing panel and testing list in different kind of wind and wave condition and tide, of course, conditions. And we have all this events. So all this, I would say, is a responsibility of Ocean Sun. And they already recently, I think they have got a DNV certification and Veritas certification, if I'm not mistaken. And they are the only, as far as I know, the first floating solar solution to have obtained this certification. So it's quite promising, I would say.
Yep. Thank you, Ms. Maha. And I think maybe one of our last question already, and maybe this question will be better for Ms. Maha to answer for the audience. So I'm not sure it's a little bit sensitive or not, but Mr. Andy Paul, yeah, his question is, what is the PV module deployed at this FPV floating solar project? Yeah, maybe he wants to know about the brand, I guess.
I'm not sure I can share that, unfortunately.
Yeah. So yeah,
I
maybe
think with a little bit of research they can find it, but I'm not sure I'm allowed to share that. Sorry.
Yeah. So Mr. Andy Paul, maybe you can find this information on the Canopy Power LinkedIn or website later. Yeah.
Maybe.
So Dr. Stefan, I'm not sure if I missed any question so far in the chat box. Can you help me check again? Yeah.
Yeah, okay, I can check.
I really like all the questions from the audience. Very engaged and very on point question.
Right.
I'm impressed. Thank you very much, everyone.
Yeah, thank you.
Yeah.
Some of them are more common, I think. I think
yeah. So I guess I think we already clear all the question. However, if any audience have any other question for any speakers here, please let us know, and we will convey the message to the speaker, and we will get back to you via email, etc. Yeah. So if not, I think it's just also a good time for us to call it a day. And again, thank you to all our speakers here, Dr. Stefan, Dr. Serena, Ms. Maha, Aidan, and for your very valuable sharing about the floating PV for all the audience today. And maybe Dr. Stefan, maybe you can say something to conclude.
Yeah, I also want to thank our excellent speakers for their presentations and for answering all the questions. And then obviously I want to thank Danny for moderating here and doing an excellent job. And also, very nice to see that we have so many comments and questions from the audience reaching almost 110 people at some point in time. So this was also very nice to see and illustrates the importance of the topic of floating solar PV. I think a lot of people do honeymoon trips to the Maldives. At least that's what my wife said. So if one of you actually does a honeymoon trip and takes a photo in front of this floating solar PV system, send it to us. We put it on the website. Definitely. And also then, finally, I would again welcome all of you to consider joining us for the World Conference on Floating Solutions 2026 later this year in October in Singapore. So yeah, I leave this open, I think, another minute. If you want to write something in chat or thank the speakers again, then please do so. But since we are 15 minutes over time, I will afterwards then make a cut.
Thank you very much, Stefan, and thank you, Danny, for organizing this great discussion. Thank you. Thanks, Serena and Aidan. Bye.
Thank you, everybody, again. I hope
have a good one.
Thank you. Yeah. Thank you. Bye-bye.
Bye. Have a nice day.
Bye-bye.
Bye.